So I'll be talking to you today about my research I've done over the last couple of years and some new perspectives and some future plans. This presentation tries to answer a few questions why is it important to assess the natural hazards? Why is it cultural heritage important? What is the connection between these two, the cultural heritage and the natural hazards? To whom and why is important to assess and monitor the natural hazards? What is predictive modeling and how does it work? I think I'll begin with some basic introduction. Natural hazards are severe extreme weather and climate events that occur naturally in all parts of the world. Some regions are more vulnerable than others, depending on the local natural conditions. I will not go through the cultural heritage definition and so on, but the impact of natural hazards on cultural heritage has increased over the last decades. Protecting the diversity of cultural heritage is a constant and difficult issue, which differs from country to country and from region to region. The destruction of cultural heritage has a long-lasting impact, and damages or destroyed sites cannot be recovered in the future. The early 70s has revealed the beginning of such academic work by the North American conservationists employed by the US Army. And the effect of extreme events on cultural heritage has been acknowledged, and this has now become an area of significant research activities with a number of case studies focusing attention upon cultural heritage in different parts of the world, including a better understanding of associated geomorphological processes. Is it mandatory?
If you want, can you hear it?
Yeah. Perfect. Then monitoring and saving as much spatial data as possible will lead to a better understanding for local authorities and stakeholders to plan economic activities, and then to mitigation and management plans, minimize damage costs, and improving environmental protection. I will not go through these details because so predictive modeling is a process through which a future outcome or behavior is predicted based on the past and current data available. Each model is made up of a number of predictors, which are variables that are likely to influence future results. And once data has been collected for relevant predictors, a statistical model is formulated. The methods are divided into qualitative and quantitative methods. So the methodology I was trying to gather around, suppose we use a lot of old maps, a lot of field surveys, aerial photos, a lot of archaeological field work, and some 3D laser scanning to in order to monitor the geomorphological processes that I will present. This is one of the study areas. It's located in the northeastern part of Romania, at the contact between Moldavian Plain and Suceava Plateau. It's an area with a very high density of Neolithic sites. Actually, this is the site where the famous Cucuten culture was discovered. Here I was trying, I did assess the vulnerability of cultural heritage sites to natural and anthropic elements. We use a set of natural and anthropogenic elements like gullies, landslides, ponds, villages, and roads. We used maps starting from 1894 until 2012, from which we digitized each element that you see here and then I applied some weights to the elements, and then we got the final vulnerability maps, which shows how this vulnerability evolved over the time since 1894 until 2012. And following the analysis, you can see the number of cultural heritage sites under the high pressure of vulnerability classes has evolved over the time. Further on, here we applied the land susceptibility models to cultural heritage sites. This was more of a methodological paper. We tried to we use GIS-based evaluation of diagnostic areas in landslide susceptibility analysis from Bahluiesc River Basin. It's a basin that has about 600 square kilometers. The highlights of the study was to see how many Neolithic sites are located in areas with high and very high susceptibility to landslides. So first we tried to compare the predictive strengthness of different diagnostic areas, which were the middle of the landslide scarp, and the landslide area. And then the most important factors of landslide triggering in this catchment are slope, land use, landforms, and lithology. As the final output, the result was approximately 70% of the sites of the Neolithic sites are located in areas with high and very high landslide susceptibility, which puts them in danger in of future degradation. The landslide susceptibility maps, the final maps, can be used in hazard mitigation, disaster preparedness, cultural heritage preservation, and protection. Among the three methods used, we used statistical index, frequency ratio, and analytic hierarchy process. Out of these three, statistical index had a better predictability. So here is the study area. These are the conditioning factors that we have used to produce the final susceptibility maps. We have aspect, land use, precipitation, slope, and others. Lithology, aspect, and topographic wetness index. So this is the data that we used in the study. We divided our landslide data into training landslides to build the model, and into testing landslides, then to test the predictability strengthness of the model. These are one of the most important Neolithic sites in this catchment. As you see, they're all affected by landslides. This is the limit of the site. This is like a huge landslide on both sides of the settlement. And this site, it's also affected by landslides and by river erosion. So these are the final landslide susceptibility maps produced with frequency ratio, statistical index, and analytic hierarchy process. These are the success rate curves and the prediction rate curves. As a final output, we have obtained really good results following using these three methods. And as I told you in the beginning, statistical index proved the best validation. Then we choose to analyze the erosion of some sites. As I told you, it's the site that is located here. We have monitored the erosion of the site. We did some 3D laser scanning, and here are how the edge of the site evolved. Apparently, having almost each year archaeological excavation influences a lot the erosion process. And how the river has meandering the site. The next site, for the next site, we also did some geophysics, so that we have highlighted the importance of the site. It's a fortified settlement with protective ditches. Also, like this site is highly affected by a landslide. Also, like on the steep slopes, there's a lot of sheet erosion. A lot of archaeological remains are washed down the slopes. And here is like we compiled a detailed geomorphological mapping with like inside this huge landslide, there are many small landslides, which we have lighted the scarps for. A lot of sheet erosion, and at the bottom of the landslide, we also have gully erosion affecting the site. This was a newly discovered site using some my colleague did some aerial photos, and we discovered this site, and we decided to make some again some geophysical prospection, and the site is also like susceptible to landslides in this in the northwestern part of the site. The next paper was again focused on the same study area, but this time we focused on gully erosion, which was like one of the main methodological problems of this paper was to debate is like it's if overgrazing is really influencing the developing the starting and the developing of gully erosion. We finally discovered that it doesn't influence a lot the gully erosion. So again, we divided our data into training gullies, testing gullies, and we use the same Neolithic sites. Again, like we used the same conditioning factors, and as a novelty, we added the density of the sheepfolds, which was the main novelty used in this paper. So these are the final gully susceptibility index produced with frequency ratio method, and which we included the sheepfolds, and this was not including the sheepfolds, and this including the sheepfolds as a conditioning factor, and this is the statistical index method without and with the sheepfold density as a contributing factor. Finally, we got very good validation of our gully susceptibility index models. So they are very, we could say that they are really reliable for the local authorities, also like archaeologists and geographers as well. In the upper part of the basin, there are like some management plans and anti-erosion measures, which are like to build concrete thresholds to stop the gully erosion process advancing and destroying the sites which are located here. This including the plantation of black robust in the upper part of the gully, and this is like you see the photos. This is like we're monitoring this gully starting with 2008. Each year we're going there and we survey the edges of the gully. And after the building of the concrete thresholds, as you see here, the erosion has considerably decreased. Also, like following the study, we we concluded that 67% of the sites are located in areas with high and very high susceptibility to gully erosion. Next work was to land use. We followed, try to track the land use changes and dynamics over the last century around the churches of Moldavia, Bukovina, from northern part of Romania. As you know, the churches of Moldavia, Bukovina are listed in the UNESCO World Heritage List, and we use land use dynamics by means of remote sensing and GIS techniques around them. A diachronic analysis was performed over a time span of approximately 100 years. And we concluded that the natural processes and anthropogenic interventions have a significant role in the land use category changes. In order to highlight the spatial fragmentation degree and land use dynamic, we calculated indexes of landscape metrics using patch analysis tool. Among indexes of landscape metrics, we use Shannon's diversity index, mean shape index, mean patch age, and patch richness. This is like a flowchart of the methodology we have implemented. And these are like the churches and the location of them. These are like the final results. We obtained very good results, which has highlighted like very interesting facts about how the land use has evolved over the last 100 years. And here, like, we have some example of contrast between specific old houses and new houses. You see the specific old house here, and I call them monstrosities of the modern world. Putting them near these ones, they look horrible, and this is like a heritage of the communist era. And a lot of these areas are subjected to floods, to natural hazards. This is like a plan that there was a huge flood in 2005, and you can see how many houses have disappeared from the area that was affected by floods. This is the Voronezh monastery here, and the anthropogenic interventions around it. This is like the houses that fit the landscape and the things that don't fit in the landscape at all. We did another study, was to highlight the shoreline dynamics and evaluation of cultural heritage sites from the shores of large reservoirs. Here is a study from around Kubyshev Reservoir, Russian Federation. The main objective of this paper was to follow the Volga River modifications and after the building of the Kubyshev Reservoir. And around the reservoir, we have a number of 1,289 sites, of which like a lot of them have been destroyed. Not affected are only 198 sites. This was the monitoring of the only left Paleolithic settlement. We did like with old Russian maps, Soviet maps, and modern field surveys with drone and GPS. It has highlighted, we have highlighted like the site has almost all been destroyed. Around 70% of the site had been totally destroyed. This is like a future work in progress. We're trying to make an archaeological predictive modeling in northeastern Romania for the Neolithic sites. Until present, various qualitative and quantitative methods have been applied in archaeological predictive modeling, among which analytic process, maximum entropy, logistic regression, and we're trying to implement and test the use of new statistical methods in APM. We're trying to use frequency ratio and statistical index. But as I said, this is work in progress. We have just gathered the data and hope I will be able to present the results at a future conference. These are like some references I used in the presentation.